And in this video, I'm going to look at electricity and fire, and this is the third one I've done, and it'll be the last one, at least for now. So the last experiment I want to try and do and see if electricity can jump through 4 flames. I plan on using only 2 devices here. The first one is the high voltage module that you can get on Amazon, and the second one is the neon transformer. The high voltage module puts out 30 kilovolts at 10 milliamps, and the neon module or transformer here puts out 6,000 volts at 40 milliamps. And even though this has more voltage, these 40 milliamps, which is 4 times the 10, mean a lot more. This could be lethal for sure. This is not. I've been shocked with it many times. Setup is to take 2 boards. This is what I'm hoping to do. One on the bottom, one that sticks up here vertically, and take the vertical one here and drill 4 holes in it that are the same size as the bottom of the long white candles, and stick each candle into each hole like this, so they'll stick out horizontally like so. So when you light them, the candle from here hopefully lights this one, then this one, then this one, meaning that all 4 flames are connected. It's pretty simple. I'll probably start with this first, the neon transformer. It is stronger, and I'll be putting 2 pins. I'll have to support these somehow. I don't know how yet, but 1 pin in the bottom flame, top pin in the top flame, and turn it on and see if we can't get a spark that goes through all 4 flames, which would be about 4 to 5 inches. And then after we try that, depending on what happens, we'll use the high voltage module here and do the same thing with the pin on the bottom flame and the pin on the top flame. So that's it. Let's go do it. For the last part of this video on electricity and flame, I took a piece of wood here and I drilled 4 holes, 3/4 inch apiece, and I'm going to put each one of these candles in here like so. And then I plan to tilt it on its side, and hoping that every flame will touch the one above it, and we'll see if we can't get any electricity to travel through multiple flames. So I've crammed all 4 candles into those holes, but I think I'm gonna melt them down at the bottom here just to make sure it sticks to the wood better. I've also burned them down, each one of them, to a point I can measure accurately the distance between each of the wicks to make sure they're all the same. When I first lit a candle, I put it on its side, measured its flame to be about 3 centimeters. So each one of these candles are 3 centimeters apart, and I've melted the bottom in here of each one to make sure that they stay that way. I fastened the 4 candles in their holder here to this larger piece of wood, and I just need to hook up a power supply here. I think I'm going to use the 6,000 volt neon transformer, since that gave us the clearest indication of electrical current moving through flames. Before I go, I got to show you this though. This is kind of fun. This is my final setup. The candles, of course, are lined up as we looked at earlier, and then I took the 6,000 volt 35 milliamp neon transformer, put this paint stick, drilled a 1/4 inch hole, which these wires fit in with the insulation perfectly. So I have one down here that will obviously be in the first flame, and this last one here, which will be close to the last flame. Okay, ready to go here. I just added the small plastic cap here to collect any wax that might drip. I don't want to ruin that piece of wood there. So here we go. I'm going to turn the camera light off, light this here, give it a second for it to build up to the next one. And there we go. All right, on the count of 3, 1, 2, 3. Well, it affected the flames, but let's try that again. On the count of 3, 1, 2, 3. And something's going through there. Turn it off, it reacts again on the count of 3, 1, 2, 3. Okay, not quite the reaction I was hoping for. Almost the same setup as before. I couldn't give up on this, so I attached the DC high voltage generator connected to an 18650 battery to a switch here. So we're going to do the same thing just to see if anything different happens. I've turned off the light. Let's light this thing up. Takes a second for it to build here, so we'll let it do that. Okay, here we go. 3, 2, 1. Well, that's really interesting. Problem is the flames have all diminished again. Not sure why. Let's move this one a little bit closer to the flame there. There we go. 3, 2, 1. Yeah, much more dramatic effect than the neon transformer. Turn it off. 3, 2, 1, turn it on. No sparking, but that's certainly interesting as all 4 flames are pretty dramatically affected. Same setup with the DC high voltage generator. The only thing difference is that this pin right here I moved down about a ½ inch closer to this wick right here than it was before. Okay, I've turned off the lights here. Let's light this up. And turning on the high voltage generator, 3, 2, 1. No sparking, but look at that top flame, man. It is spastic. Turned it off. Again. 3, 2, 1. Okay. Pretty interesting setup, except I switched the polarity of this pin here and this pin. I've turned the lights off. Let's light this thing up. 3, 2, 1. Pretty much the same result. Maybe a little stronger at the top there. 3, 2, 1. Almost wants to put that top flame out. And there's some sparking happening. Very tiny sparks. You probably can't see them, but that's what those ticks are. Okay, that's what I was hoping for.